David Smith here with another Flip Classroom math video. A few tips before we start. Remember that you can slow down or speed up the playback if that helps you follow along. You can also pause the video at any point to catch up with your notes or to try the problems before I explain them. Finally, you could turn on the captions and read my words below on the bottom of your screen. Today's topic, exponential functions and translations. So let's take a look. Generally speaking, an exponential function has the variable in the exponent. So the variable is the exponent. So in this example, it's some base a to the x power. And x is what we change, and f of x is calculated by raising this base power to the x that we picked. So the example function that I'm going to graph here for you is f of x equals 2 to the x. This is your basic doubling function, because every time you increment your exponent, you're going to double your previous value. Okay? So let's put in our little t-chart here. Minus 2, 3, minus 2, minus 1, 0, 1, 2, and 3. And let's take a look. So if x is negative 3, that would be 2 to the minus 3, which is the same as 1 over 2 to the 3, which is 1 over 8. So this is 1/8. This one, in a similar way, is 1/4. This one is 1/2. This one is 1, because that's 2 to the 0 power, that's 1. This one is 2 to the 1. This is 2 to the 2, which is 4. And this is 2 to the 3, which is 8. So if you're unsure about how I got all those numbers, you might want to pause the video and take a look at how this function works and what happens with negative exponents to get the fraction answers, and so on and so forth. Moving right along. Let's graph our points. Negative 3, 1/8. That's like right there. Probably even a little bit lower. Negative 2, 1/4. A little higher. Negative 1, 1/2. 0, 1. 1 gives us 2. 2 gives us 4. And 3 gives us 8, which is somewhere up in there. So we're doing something like this. And that's exponential growth given by f of x equals 2 to the x. A couple things to notice. It cuts the y-axis at the point 0, 1. And a lot of exponential functions do that. Another thing to notice is that it's approaching the x-axis as we keep going negative. So it's never going to touch it, it's never going to cross it. A way to think about that is, as we keep getting bigger and bigger negative numbers, the number on the bottom of this fraction is going to get really big. So it's going to be 1 over really big, which is really small, but it's still positive. So this function has what we call a horizontal, Z-O-N-T-A-L, asymptote at y equals 0. Which is the y-axis. It's this line, y equals 0. So the function keeps getting closer and closer to this horizontal asymptote, but it does not reach it. Okay, we're going to jump into Desmos and play around with some basic exponential functions. Remember, Desmos is an awesome tool. It should be your go-to tool if you need to compare and understand graphs quickly and easily. Just remember, you're still on the hook for creating hand graphs occasionally. Okay, here I am in Desmos, and I've got our basic doubling function entered in already, y equals 2 to the x. So let's play around and see kind of how these things change. The first thing I'm going to do is just play with that base. So let's try y equals, now I'm going to do 3 to the x. Now I want you to think, before I put that in there, what's going to happen to the graph? Okay, here we go, 3 to the x power. Check it out. This is a tripling function. Each time you add a new x, it's the power of 3, so we're tripling one more time. And it makes sense. This black function is increasing faster. Now, do a prediction for what would happen if I entered 1/3 to the x. Okay, so I'm going to go ahead and type that in. Y equals 1/3. Now I'm going to hit my arrow to get out of the fraction on the bottom, and then put my caret x, my exponent. So check it out. Now that made a much bigger change. Now we're decreasing. This is, instead of a tripling function, this is a 1/3ing function.
So each time we put x in, it's to the 1/3 power, or it's 1/3 to that power, which means that we're actually decreasing. This is a decay type of function. Okay, let's enter in a few more. Let's try y equals -2 to the x. Now check that out. I've just inverted that function around the x-axis. I've reflected it. There's a hint to how we're going to be doing some translations a little later. Let's try getting a little bit more outlandish. Y equals 2 caret x plus 5. What happened there? Check it out. I just took that doubling function and I moved it up 5. Remember how we talked about horizontal asymptotes? This one has an asymptote at y equals 5, not y equals 0. I'm going to take that one out. I want to make one last point. Actually, let's take this one out. As long as I have a basic function with a positive base, it's always going to intercept the y-axis at the point 0, 1. Another way to say that is if we haven't done a horizontal or a vertical slide, a translation, it always goes through that point. And this makes sense because that's whatever the base is to the 0 power, and that's always going to be 1, no matter what that base is. Now in your exercises, you're going to explore more variations on this when you're calculating points and thinking about graphs.
Now that you've finished, take a moment to write down any questions so you can bring them to our next class and get some help. You can also watch the video again to improve your understanding. If you enjoyed the video, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.